We would like to start the seminar about New Manufacturing Proposals, Electric Switchboard Version. This is a 15-minute video presentation. We would like to begin with the electric switchboard market in the world. The power demands are growing rapidly in recent years, especially in economic growing countries such as China, India, and Brazil. We also see global increase in power demands since we are moving to a next generation social system called smart grid that optimizes energy efficiency. Based on these backgrounds, the global market size for the electric power distribution is expected to grow twice the size in the 10 years, from 2010 to 2020. The companies are, however, required to differentiate their products with short delivery and customization while complying with the standardized functions such as durability and strength within severe production cost restrictions. Also, from manufacturing perspectives, it is thought to be easy to manufacture since they are box-shaped, but each customer has different way in size of electric equipment or setting ups, and they are therefore actually high-mix, low-volume production, resulting very difficult for improvement in efficiency. Therefore, lead time and cost reduction are required in both the design process and manufacturing process, and reform for new manufacturing is imminent. Now, we will show you a case study for improving efficiency with outdoors distribution board used for solar power generation and busbar electric components. First, we will show you the reduction of machining process of busbars. Busbars are used to distribute electricity by connecting terminals and breakers inside the electric switchboards. It is made of copper and coated to silver color. Busbars blanking process are generally done by machining or punching. Today, we would like to introduce the cutting of copper with fiber laser machine as a new processing method. As you see, fiber laser machine enables high speed and high quality cutting of copper. This was made possible by the different characteristics of the laser beams. The wavelength of a laser has a correlation between beam condensing and reflective ratio. Let me briefly explain their characteristics. The traditional laser with long wavelength has large beam condensing diameter. By contrast, fiber laser with short wavelength has smaller beam condensing diameter, so the energy density at the focal point of fiber laser is higher. Also, when laser beam is applied to the metallic material, longer wavelength of traditional laser gets stronger reflection. By contrast, fiber laser with shorter wavelength gets weaker reflection. Therefore, fiber laser can cut copper that is generally called highly reflective material with high speed since laser energy can penetrate efficiently. From here, we will show you how to increase work efficiency with outdoor distribution boards as an example. First, we will introduce the new blanking method that will eliminate the painting preparation task. Various durability performances are required in distribution boards used outdoors, and one of them, resistant to corrosion, is a particularly important factor. One of the spots that are susceptible to rust is the end face of sheet material. It depends on how it is painted, but if the edge of the end face is sharp, the coating painting is thin and is more susceptible to rust. By finishing the sharp edge of end face into radius, the thickness of paint on edge is more even, therefore less susceptible to rust. So the sharp edges are round chamfered by hand before the painting process. Today, we will show you how to reduce the lead time and stabilize quality by incorporating the round chamfering process automatically into the blanking process. Round chamfering is done in two steps: pre-hole, then R chamfering on both sides. First process is the pre-hole. Second process is the R chamfering on both sides. Round shape is formed by progressive feeding process, so the process length can be set freely. Here we use the tool to feed at 18 mm pitch. Pre-holes can be done by punching as well. The overlap marks and burrs from this process can also be round chamfered. Next, we have two proposals for improving the bending efficiency. It is very hard and difficult to get a right angle for large and heavy material. If the production lot is small, your workload is even heavier. Bending angle sensor enables correct angle from the first try even for new orders. Besides, reducing the lead time of bending process, the quality of the next welding process will be improved. Also, gauging of large size material is difficult and hard. If the distance between the bend tool and bag gauge position is far, dimensional accuracy will not be steady due to the difficulties of material horizontal gauging. In this case, bag gauge with support fingers should be used for speedy and accurate bag gauge positioning. The bag gauge position is automatically calculated by pressing the button on the operation panel. Next, we have two proposals for improving the welding efficiency. When welded section is made like a radius shape, the setback amount is half of sheet thickness. This setback positioning is very difficult. Here we introduce nail tip forming that effectively reduces the positioning workload. By adding this process, setback of half sheet thickness can be done easily. This will not only reduce the positioning time of tack welding, but also improve the component accuracy. Also, the back surface is flat, so finishing process is not necessary. The nail tip forming in the blanking process will be done in a single process. Press material swells and forms the nail tip shape. Next, our proposal is for reducing the finishing process. With general welding such as TIG, finishing process is required after welding. However, the latest high-grade fiber laser welder doesn't require finishing process, and significant lead time reduction is also possible. Less heat distortion is one of the main characteristics of fiber laser welding too. Lastly, we would like to propose efficient programming. For complex shapes like these, time is spent with the study of bend sequence, tool selection, and welding feasibility in the programming stage. By utilizing simulation, feasibility checks are done easily in short time and eliminating reworks at the shop floor. Here, we would like to introduce our latest blanking, bending, and welding solutions that utilize the processing technologies we have just introduced to you. The fiber laser machine FOL-AJ is for high-speed, high-accuracy cutting of various metals, including stainless steel, aluminum, and copper. The punch laser combination machine ACIAS and the punching machine EMZR are for integrating multiple processes into blanking process and effectively realize automation of high-grade processing. The next generation hybrid drive bending machine HG is for realizing high productivity for complex shape bends and radius. The fiber laser welding machine FOW is for realizing high-grade processing, challenging the boundaries of welding processes. From blanking to bending, the punching and L-shaped shear combination machine LOSC and the panel bender EP are the automation system line for high-mix low-volume production. We have introduced our leading-edge processing technologies and solutions that will change manufacturing to you today. Amada has been endeavoring on systems to reduce the lead time of high-value added products without depending on skills in all process stages. Amada's new manufacturing proposals will drastically change today's sheet metal processing. We will continue to work with customers in solving manufacturing issues. Thank you very much for your attention.